What's poppin', y'all? It's Colonel Tommy with episode 5 on my road from Scrub to God Tier Programmer. It has been a long time since I've been on here. And the reason being is I've been in college and I haven't had any other time to do anything besides schoolwork. But I'm graduating surprisingly, and I'm going to be looking for a job now, and I'm practicing my coding again to make sure I'm ready for any coding problems they throw at me. So with that, let's get on to the video, shall we? Alrighty, so for today's video, we're doing divisible sum pairs. So let me give you a brief overview of the directions for this one. So you're given an array of integers and a positive k value, integer k value. So you gotta determine the number of ij pairs where I is less than j and the value at I index in the plus the value at j index is divisible by k. So for example, you have this array which has 1, 2, 3, 4, 5, 6, and the value has got to be divisible by, which the k value is equal to 5. So as you can see, there's 3 pairs that meet the criteria: 1 and 4, 2 and 3, 4 and 6. Okay, so what that means is, so like 1 plus 4 is 5, which is divisible by 5, meaning there's no remainder. So let's say this, say we did 1 plus 2, you can't divide 5 by, you can't divide 3 by 5 evenly. So that wouldn't work. But if you add 1 and 4, that's 5, and 5 is divisible 5 evenly. So that's why each of these pairs work. So 2 plus 3 is 5, 4 plus 6 is 10, which would be 2 divided by 2 when it's divided by 5. So another thing to note is the I is less than j, meaning that the index of the number is less than the second index. So as you can see, the index of 1 would be 0, and the index of 4 would be 0, 1, 2, 3. So 0 and 3. So 0 is less than 3, so it works. You couldn't, however, do a pair, say you did this pair, except this was the first number, and this was the first number, this was the second number. So you couldn't do like the third 0, 1, 2, the second index plus the first index. That would not work. You'll understand more once we get into it. Alright, so the int n, so these are the, for the function, there's these 3 parameters. So you got n, which is the length of the array that you're given, and then an int array of which is an array of integers, and an int k, which is the integer divisor. And then what your function needs to do is return the number of pairs it finds. So this is, so it's the input format's gonna be the first line is 2 space separate integers, n and k. The second line contains n space integers, each to the value of the array. And these are the constraints, meaning that there will be no more. There's going to be greater than or equal to at least 2 numbers, and there will be less than or equal to 100 numbers in the array. And then the divisor is going to be greater than or equal to 1 at least, and then less than 100. And then each value in the array is going to be greater than or equal to 1 and less than or equal to 100. Reason pride is doing this is so you don't end up dividing by 0 or anything else that could cause problems with division. Alrighty, so this is what the input would look like. So you got the number of numbers number of integers in the array, the divisor's second number, and your second line is all the values in the array. Uh, so as you can see here, and then the sample output is the number of pairs you get. So with this one, this is what the pairs look like. And as I was stating before, you can see the index of the first one is less than the second one. See, 0 is less than 2, 0 is less than 5, 1 is less than 3, 2 is less than 4, and 4 is less than 5. And this is the addition values, addition of them. So 1 plus 2 is 3, 3, 9, 3, 3, which are all divisible by the k value 3. Meaning there's no remainder for the division. Alrighty, so let's get into the code, shall we? Alright, so where do we start with this one? Well, we're going to be counting the pairs in this code. So we need a value to hold. So I'm going to do an int value variable that's going to be equal to 0, and we're going to call it pair count. That's going to keep track of our pairs. Now, we need to go through each index in this array. So we can, let me scoot this over so it's a little bit easier to read. Alright, so obviously we're going to have to traverse the array. So we're going to need some kind of for loop. So we're just going to do a for loop with I equals 0. I is going to be less than n and I plus plus. Alright, so what did I just do there? So this is to traverse the entire array that we're given. As you can see, this is the function that it's calling. So the parameters are n, which is the number of elements in the given array. So that's why that's what this n is. And then k is the divisor, and then you got the array the array that it passes in. Okay, so we got the array, so we're going to go through each number in the array. However, we need to compare the values of each. We need to compare each of the values after it. So like, we need to be able to compare 1 and 2 to see if you add them together, you can divide it by the k value. So we're going, and we need to do that for every other value in the array. So we're going to need another for loop. So we're going to do another for loop. We're going to call this one j, and then j is going to be also less than n for the number of elements in the array. And alright, so we got nested loops here. Okay, so now for the part I was trying to explain earlier. So as you noticed, the index of the first number has to be less than the second number. So that's one thing we need to check for. So easy way to do that is we're going to put if I is less than j. Because as you can see, we're going through we're starting back at 0. If we just do if we just check if I is less than I is less than j, it won't do anything else if it is greater than. If j is less than I, then we'll have a problem, and it won't do anything. So we're not going to count any pairs unless I is less than j. So let's do, next thing we need to do is get the sum. So we're going to have a variable called sum, that's an int, and we're going to call the array get value, and we're going to get the value at I, and we're going to get the value at j. So for the sum, we're going to add the value that's at the I index, and then we're going to add it to the value at the j index. So we're basically going through each. We're starting from 0, and we're going to check for the index. So it's going to start at 0 for the j, and then it's gonna go in the first loop. So I is gonna equal 0, j is gonna equal 0. So that is not gonna work because I is not less than j. So I'll skip to the next one. So j is gonna increase by 1. So it's gonna be I is gonna be 0, j is gonna be 1. So now 0 is less than 1. So it will get into that if loop. So now we're going to do the sum. So it's going to get the value at I, which is 0, and then it's going to add it to the value at j, which is index 1. So say we were doing this sample input, it would get, so the value at I would be 1, and the value at j would be 3. And we're going to add them together, which would be 4 if we are using these two values. Okay, so we got the sum, and it'll do that for every value. It'll get the sum of every possible pair. So we have a sum. Now we need to check that sum to make sure it's a valid pair. So how do we do that? Well, we're going to do an if statement and sum, and then we're going to do sum. That's the modulus to make sure that so we'll do modulus k equals 0. Okay. You might not know what that does. So what that means is sum, so say that was 4, and then modulus k, which is percent. I just dragged it over. My bad. Alright, k. So k in this instance would be 3. So what that does is like division, but the result is the remainder. So we're checking if the division, so sum divided by k, if the remainder is 0, which would mean it divided cleanly into it. And for instance, if it was this one, 1 plus 3 would be 4. 4 divided by 3 would have a remainder of 1. So that would not work. So, however, if it was 3 and 2, alright, sorry, not 3 and 2, 1 and 2, that would be 3, and then divided by 3 would have a remainder of 0, which would work. So that would be a pair. So then we'd want to count this pair. So we're going to call our pair count variable, and we're going to do plus plus, which means to increment it by 1. So once we find that pair, it'll be 1 now. And then now, for every pair in the array, it's going to go into here. It's going to sum them if the index is less than the second index. And then it's going to check the sum mod k the k value is equal to 0, so it divides cleanly, and there's no remainder with a remainder of 0, then we're going to increment the pair count by 1. So now we have everything we need. So the last thing we need to do is return our pair count. And that's it. Now, of course, there's probably more different ways you can do this, and that's fine. You can probably make this more efficient if you wanted to. So let's run it and make sure this works. And look at that. It passed all the test cases. And yep, we solved the challenge. Yeah, I'll leave it here for a second so you guys can see everything. But yeah, it's actually fairly simple. For these, you just kind of have to understand the problem. And once you understand that, it's actually quite easy to implement. Well, thank you guys for joining me. I'm glad I'm back, and I'm hoping to have more regular videos as I work through these problems. Well, thank you guys for watching. I'll see you in the next one.